Thanks again for everyone who has joined. And in this session, I'm going to be going through some rather exciting updates in the world of Conveyor. Conveyor is one of our proving ground apps that we have available for purchase and trial on the Proving Ground website. And what Conveyor is it's a Rhino and Revit integration solution. And as I go through this presentation, I'm going to kind of use this as an opportunity to not only provide some context around Conveyor and how it has evolved and what some of the new version 3 features are, but I'm also going to try to position Conveyor in a way that explains why we feel this solution is needed in the marketplace among other available solutions that are out there. And I think one of the biggest drivers for us for building out this toolkit is that we have this kind of fundamental belief, having kind of ourselves experienced different workflow solutions, developed different workflow solutions in the past, that there is a need for highly simple, effective, and user-friendly workflows. And one of our, ambitions with this toolkit, specifically when it comes to moving information from one modeling platform to another, that the workflows shouldn't be complicated. They should involve a level of integration, almost invisibility to the process, and we try to boil down this kind of philosophy to a simple sort of statement: is that if you know how to click on a 3D object, which is like the most, I would say, fundamental thing that you do when you go into a modeling environment, is you can click on an object, that your workflow should work. There's, I think, a problem that's existed for a very long time when it comes to managing data and geometry between different modeling environments, that has especially proprietary modeling environments. And oftentimes I think users are stuck between two different kind of paradigms that I think offer different advantages and different disadvantages. On the one hand, you have a deluge and spaghetti network of intermediary file formats. This is something that I've personally have been interested in navigating for years, especially when you look at the different modeling challenges that we've had to encounter when it comes to receiving information in one file format, having to convert it to another file format, bring it into another application, another file format. It can get really complicated really fast, and it's sort of very manual, very laborious, and time consuming. And it's kind of the way that you sometimes have to do things when it comes to kind of bridging between applications when they're kind of provided to you out of the box. These are kind of the out of the box compatibility solutions that are often present. So like importing ASYS SAT files or even IFC files, those types of file exchange formats are pretty prevalent, and it kind of results in this kind of process spaghetti. So users often have to navigate this. And on the other side of things, we have kind of what we would characterize as kind of more specialized solutions, i.e. needing the kind of requirement of having to have certain skill sets in computational design software, or even having to code directly. And one of the kind of more out of the box ones that's become quite popular in the last year or two has been Rhino Inside, which is an extremely powerful computational design solution that lets you launch Grasshopper through a place like Revit, and that kind of provides you with a portal for interoperating with Revit data from Rhino. And it's quite extensible. There's many options. The downside that we see is that it's also based in Grasshopper, which can be very intimidating for users that might just be experienced conventional modeling individuals, which make up quite a large majority, I think, of many users out there. And so we've kind of seen a need still to kind of think about the paradigm of a user that needs to be able to navigate 3D software, bridge the gap that often exists between different 3D software, and the power that comes from these integrations that offer different pathways like Rhino Inside. And so we've kind of set out a couple of, I guess you could call them development guideposts to where kind of Conveyor kind of situates itself within this situation, right? The idea that workflows should not require necessarily coding or computational skills as a baseline. If you're a user and you're working your way through a challenge, what you don't want to encounter necessarily is this idea that, I need to kind of learn a whole new modeling paradigm in order to move my information from point A to point B. We also understand that workflows need to be flexible and adaptable. No project in the world of architecture and design is one size fits all. We need to be able to have a workflow that can be adaptable to many different circumstances. And finally, kind of relating to bullet point 1, but I think kind of putting a finer point on is that workflows should be able to scale to many users. And I kind of refer back to maybe some early experiences that I've had where on projects, you might kind of build out a very bespoke workflow solution that works on one project and may be kind of managed by a couple of individuals. But we also see an opportunity here for workflows to have impact across a variety of individuals in a firm, on a project team. And so we're like kind of looking for those abilities to create integrations that can be adopted by a general population of users with different skill sets. Some might have very basic modeling experience. Some might have more kind of advanced computational experience. And, we think that workflows, especially at an organizational level, need to have this consideration in mind in order for them to be kind of as impactful as they could be. So that kind of brings me to where we're at with Conveyor version 3, and I think Conveyor in general when it comes to the different workflow paradigms that we're addressing, some of the new features that we have coming out that we're pretty excited by, and ultimately we'll kind of lead up to a bit of a demo here towards the end as well. So Conveyor operates kind of within two, workflow paradigms. On the one hand, we provide tools that allow you to import external data into Revit from a Rhino context. So the idea that you might be in Revit, you're able to select a Rhino file, pick objects, and bring them in as you need. And we've also extended Conveyor as a version 2 last year with the Rhino Inside paradigm, meaning that within Revit, you can open up Rhino Inside, and then you can also use our kind of user toolbars to migrate Rhino geometry over into Revit without having to necessarily use Grasshopper either. So it kind of provides a kind of a Rhino direct connection, which I'll talk about. But I'm going to start with the import paradigm, which really involves a reliance on OpenNURBS, and what OpenNURBS is the 3DM file format that allows you to kind of save a Rhino file. It's a very powerful file format in our experience, and the ability for Conveyor to work is really much based on the availability of what McNeil has provided as an open file format with OpenNURBS. So meaning that as a user authors, whether through direct modeling or scripting or through Grasshopper, this data can be saved to a 3DM file format as Rhino objects. We can use Conveyor then to migrate those objects into Revit elements. And the way that we do this, and the way that we accomplish this, is that we're able to sort of say, well, you have these different geometries. If we can allow the user to have access to these geometries and then provide some data about what these geometries are in the Revit context, then that we should be able to create these objects and have them be native Revit elements that you can kind of use in your production workflow. And so that's kind of what this slide starts to get at, is that if you might have a volume or a solid or a surface or something like that in Rhino, the conveyor user interface allows you to kind of basically tell conveyor what this object is in the building information context. And then Revit and conveyor will create them. And from a practical perspective, you might have a scenario like this, where you're kind of sketching up conceptual geometry directly in Rhino. A lot of design work happens directly in Rhino today, and you're able to then classify these objects and bring them into Revit. And then the idea being that these objects should be flexible and have this ability to be built upon and used in the general Revit production stream. So the idea of going from surfaces and solids to BIM elements that can hold data, be built on with other elements, can be documented, used to bound rooms, and provide other possibilities within the general production, is the driving, I guess, philosophy behind this particular import workflow. And we've since begun to expand this kind of flexibility as well. One of the things that we've observed in these types of workflows is that you bring an object into, say, Revit, and it may come in as if you're familiar with Rhino Inside, or if you use Conveyor in the past, you might find that some of these objects convert as what's called a direct shape. Direct shape is a kind of an in-place component in the Revit environment. If you model shapes directly in Revit, what we're able to do with now with Conveyor version 3 is we've started to introduce some utilities that allow users to perform a task on their direct shapes that have to date, I think, been very difficult to achieve without having to kind of re-import things. And that's the idea of assigning materials to your direct shape object. Typically what happens is if you bring in a direct shape, it might have materials assigned to it already, or might have no materials assigned to it. And then once it's in Revit, you really can't edit these in any meaningful way. And so with Conveyor version 3, we've introduced a direct shape material integration utility, allowing you to select your direct shapes, override the materials on those direct shapes, select individual faces on those direct shapes and apply material to them, which we think kind of extends the value of these object types in a building information model context, and makes them more flexible to users that might need to make quick updates to their imported objects without having to go through the whole entire process of re-importing things in or changing things in Rhino. So this is a new utility that will be a part of the Conveyor version 3 toolkit when it comes to material assignment. And I think what we'll as we'll kind of discuss, materials and support for materials and kind of creating faster workflow integrations across the Rhino and Revit environment is definitely a theme in version 3. Another thing that we've felt very strongly about in general, since I think even the first versions of Conveyor, when it comes to supporting these workflows, is giving users resources to understand how a workflow can operate for them. And I think when we think about interoperability, and when we think about kind of jumping between applications, it's actually a kind of a challenging thing to orient people to. Oh, we have this interface that can import something externally of the application I'm familiar with. What is that actually doing? What are the steps I need to go through in order to accomplish my goal? And one of the things that we've been pretty attentive to over the last couple of years, and we've expanded and will continue to expand in version 3, is the availability of resources that can onboard a user to the workflow. And one of the things that you'll notice in the toolbar that we're providing with version 3 is direct links to video learning, what's new in new versions, and searchable online help, such that when someone installs Conveyor or opens it for the first time in the Revit toolbar, they can figure out and get themselves oriented to the tools as quickly as possible, so they can start to be productive in the environment. We want to make these workflows as transparent as possible in terms of what's going on. So that's something that we're continuing to expand on, and something that we're excited about. Not only are we thinking about providing technologies, but how do these technologies become productive in the working environment. This kind of import workflow has had impacts on a number of projects that we've been personally involved in. I just want to highlight a few of them here, because I think it's one thing to talk about workflows in the abstract and show like examples when it comes to like, oh, I moved this geometry, now it's this geometry over here. These workflows have had, I think, some rather interesting outcomes on projects at a variety of different scales. This is the Gilder Center for Science Education Innovation, which leveraged a lot of Conveyor's mesh-based workflows to transmit a highly complex subdivision geometry between Rhino and Revit, such that it can be visualized, documented, and used in the kind of larger project production scheme. It was also used heavily in the Lucas Museum of Narrative Art for a kind of, I think, a general strategy for connecting external files that Stantec, which is the architect of record on this project. They would receive many external files in Rhino format from their collaborators over at MAD and elsewhere, and they needed a way for their building information model to quickly integrate these objects, and Conveyor became a pathway for that. We also had an implementation of Conveyor to support some of the production that was being done on the exterior facade on the Allegiant Stadium, which is home of the Raiders in Las Vegas. And our Conveyor Toolkit became a device for Mortenson McCarthy, who was the general contractor, a joint venture general contracting effort, to take objects from Rhino, provided by facade, their facade design assistant and their architect, and bring them into a Revit environment such that it could be used as a I guess kind of a level 300 model for design sequencing and coordination. So they took imported Rhino elements into Revit and turned it into a way for them to coordinate the installation of facade elements. And between all of these examples, it's what kind of occurs to us is that the ability to import external data continues to be extremely important, specifically when it comes to consuming information that may be coming from an external vendor or contractor or collaborator. We find that there's files moving all over the place, and sometimes you need to have a workflow solution that just lets you connect to some of those and bring them in. On the more interactive front, we are continuing to expand on our Rhino Inside integration. And one of the things that occurs to us about Rhino Inside, and specifically the Rhino.Inside.Revit plugin, is that not only does it kind of have its own kind of, I guess, Grasshopper toolkit that lets you kind of use Grasshopper interactively with Revit, which, as I indicated before, is on the one hand very powerful for Grasshopper users, but also can be, I think, quite intimidating or in some ways not quite accessible to the more the users that might just be more 3D model, direct model driven. But one of the things that occurs to us is that this actually opens up a very unique pathway, insofar as if you can open up Rhino through Rhino Inside, we can build additional user interfaces that allow for a kind of a direct access to Rhino objects and port them over. So the way that that looks is something like this, wherein you might have Rhino and Revit running in parallel with each other, and the conveyor interface exposes controls that let you select objects and click on essentially a button that will send those objects over to Revit without having to integrate or access or leverage any of the Rhino or any of the Grasshopper components with Rhino inside. We're able to kind of layer in a user interface that just allows for very simple and direct import activity. And this type of integration is something that we're expanding on with Rhino version 3 in a number of different ways. This is a video I posted not too long ago, maybe about a week ago, that shows some of the capabilities here, wherein a user is working with Revit and Rhino in parallel with each other. They may have assigned different objects to different categories. They might have designed blocks that represent things like staircases and facade panels. And in Rhino, you also are likely putting materials on these objects. And one of the things that we've done is we've created new pathways by which these different objects can come over into Revit. And we've expanded the DirectShape compatibility as well. So what you're seeing here is a user clicking on objects in Rhino. These objects have assemblages of geometry as well as material assignment. We're seeing a mapping of the Rhino object to the Revit object with materials assigned, and they're coming in as classified elements that can be used in the production workflow, which is something exciting. And it's happening very fast. And that's one of the kind of advantages of expanding the DirectShape support that we're focused on, is that those tend to be much faster conversions than family-based conversions. So this idea of handling complexity has been of a paramount interest to us, kind of handling assemblies of objects, capturing those assemblies, capturing materiality across these environments is something that we're very much focused on and are excited to put out there with Conveyor version 3. The other direction is something which is going from Revit into Rhino, is something that we've also been attending to a great deal with this particular workflow. And what that means is, the ability to click on a Revit object and send it over into Rhino for coordination. In Conveyor version 2, we introduced this, and you're able to basically select like a wall object or select another object in the Revit world and transmit it over into Rhino as a solid shape. And that's happening through the conveyor panel running on top of Rhino inside. What we've done since then with Conveyor version 3 is that we've expanded this capability to support the migration of properties into Rhino as well. So not only are you able to grab geometry out of the Revit environment and put it into Rhino, but those properties that are assigned and on top of the Revit objects are exposed in Rhino after the transfer as user text and data that can be accessed and reviewed or even tied downstream into other use cases, such as like creating an analysis tool in Grasshopper, for example. We think that the availability of properties and the availability and transfer of data between applications is almost just as important as the geometry itself. So that's something to look forward to in Conveyor version 3, which is the kind of the more direct integration of data across these platforms. And in this case, the integration of Rhino or Revit data into the Rhino environment. The other aspect of this is the ability to update objects when it comes to transferring information from Revit into Rhino. And so what we're able to do here is click on the Revit objects, bring them over into Rhino. Then we might make adjustments to the Revit objects, move a couple of walls or partitions in Revit, and we might need that updated context in Rhino. And what Conveyor does is it finds those objects and provides the update feature. So your Rhino model can stay up to date with that Revit context, so that if you're designing something that's dependent on something being built in Revit, you can continue to work with it and continue to see kind of updated coordination. We think that the idea of being able, the ability to have interoperable workflows between these environments is never a one and done kind of thing. It's not like you can import something and be done with it. Very rarely does that happen in practice. It's always kind of a moving coordination activity, and that's what we're aiming to continue to support with these kinds of workflows. So between expanding the ability to bring in objects with materials, supporting property migrations, the ability to have more pathways and more categories supported by Conveyor, we're very excited to be rolling out Conveyor version 3, likely in the next week or two. So it's coming quite soon. We're kind of going through last round of testing and deployment testing at the moment. I see a question in the chat: when will Conveyor version 3 be released? I'm going to project likely. I'm going to be ambitious and say likely next week, or the first week of February, essentially. This will be available as something to download and purchase. And speaking of purchasing options, what we can sort of project as the availability of these tools, if you're buying version 3 outright, you're looking at pricing at about $6.95 for a perpetual license. So that's kind of how we offer Conveyor generally through our website, is perpetual licenses. So there's no subscription fee or renewal fee. These are perpetual licenses that you can install on 2 devices and have them be something that you can use in perpetuity without having to incur additional costs. If you're looking to upgrade your license from version 2 to version 3, there will be a significantly discounted version price point. If you're an enterprise user, you are kind of on a subscription support and implementation contract with us, which means that this upgrade is just included. You're getting continuous updates to version 3. So when this is available, you as an enterprise subscriber will get this upgrade. And if you're in the educational side of things, what we do provide generally with our Proving Ground apps is an educational bundle discount. So what that means is that we have a number of different products. Conveyor is one. I've talked about Semantic and Tracer in the past. We kind of bundle these all together for an educational user, and then provided 90% discount across the board. So you end up with our entire Proving Ground toolkit for a very, very affordable price that can hopefully work within a student's budget if they're interested in integrating this in the workflow. So stay tuned as we kind of prepare for the rollout of Conveyor version 3. What I think I'd like to do right now is transition to a demo of some of what you just saw, kind of more of a live demo. I do see that there are a number of questions here that we can address quickly. So Steve, did you want to go through some of the outstanding questions, and I'll attempt to address them?
Sure. One question was if objects are set in place, or this is from Rhino to Revit, it sounds like, or if families are created and placed into the model.
Great question. So if I can maybe put this another way, there are oftentimes 2 approaches that can be taken here, and Conveyor supports both of them. There is a mode by which you can bring objects in as a direct shape, which is essentially like an in-place component in the Revit world. Those are very fast and direct translations that can be made, and they do support materials. There is another mode wherein you can take the same object geometry, and Conveyor will automatically create a family object and place that family object in the Revit environment. So our workflows support both. in this context. So both kind of in an in-place mode as well as a kind of more family-oriented mode in Revit.
Nate, we had a second question, which I really like this question. Since Revit has no backward compatibility, will Conveyor be able to translate objects from newer versions of Revit, push them into Rhino, and then back towards an older version of Revit?
That's actually a workflow that I've done, and it is quite valuable for sure. So the idea that, okay, I'm going to open up, let's say it's Revit 2022. Say I receive a model in Revit 2022 that's got like a number of walls or floors or other objects in, but I'm working in Revit 2020 for some reason. I need to get some of that data from 2022 back into Revit 2020. Well, the workflow there would be to open up 2022, select a number of different objects out of the 2022 environment, push those into Rhino, and then you can open up Conveyor inside of Revit 2020 and re-import those objects into Revit 2020. So it does kind of have a little bit of a, I guess you'd call it pseudo backwards compatibility. I guess it allows you to kind of have a bit of a, I guess it's a bit of a workflow hack, just allowing you to take information from one model back down to another. So yeah, it could be that's certainly, I think, an interesting approach to take.
So thinking through that a little bit, Nate, when it comes to actually family content, like pieces of furniture, for example, or what a toilet, that might not be as straightforward in terms of parameters. Can you expand on that a little bit?
Yeah, that's actually interesting. So the idea that you might have a family wherein you have a family in Revit 2022, and I guess you could kick that over into Revit or into Rhino, and we're bringing over properties with that object, and if we reconstituted that as a family in another environment, yeah, I would say it's not going to be perfectly seamless, but it certainly offers an opportunity to make both the kind of family object with its data interoperable to some degree. Again, like you start to get into some interesting edge cases with kind of going from a BIM element back to a geometry element back into a BIM element. There might be some wonkiness to sort out there, but it seems quite possible.
We had another question quickly here. If there's any dependencies on versions of Rhino Inside across Revit and Rhino that Conveyor V3 would have dependency
on? Not particularly. I think one of the things that we've tried to do when it comes to supporting the Rhino Inside integration, and the Rhino Inside integration has been something that we've had in place now for over a year, close to over a year, is up until maybe a couple of weeks ago, we were testing with an older, all the tests that we were doing with this new version of Conveyor were on an older version of Rhino Inside, and we just performed an upgrade to the most recent version of Rhino Inside, and there weren't any direct breakages. I think what often happens with Rhino Inside is that a number of things could be updating across in that particular application, right? It might be that they're expanding Grasshopper nodes and expanding capabilities of the Grasshopper nodes, which we don't touch at all. So the idea that there might be an update there, but it doesn't necessarily affect the underlying framework that makes the connection between Rhino and Revit, because what ends up happening is that we're basically using the pipeline, but we're not using the any of the Grasshopper capability or logic there. We're using our own kind of translation logic and feeding it through the Rhino Inside pipeline. So we've kind of got our own conversion toolkit that we control that should for the foreseeable future should be quite compatible with the Rhino Inside pathway that's being provided.
So I think we've got a couple questions we can put in our back pocket while you get to your demo, Nate. And while you're spinning that up, maybe you can talk about how Conveyor V3 is compatible with Semantic.
Oh, sure. Yeah. So that's a great question. Let me just spin down my presentation here and reshare my screen. Cool. Are you seeing the model, Steve?
Yep, I can see it.
Okay, great.
It looks
So,
fancy. I like it.
Yeah. Thanks. Thanks, Steve. Yeah, so Semantic is, for context to everyone on the call, Semantic is a Rhino property editing environment that we provide and publish. It allows you to create and manage property groups and manage the kind of assignment of different object types. You can schedule and kind of have live updates of data from your Rhino objects. And we also kind of provide an integration with Semantic and Power BI. And so the question here is Conveyor version 3 compatible with Semantic? And I would say yes, it's as compatible as Conveyor ever has been, insofar as if you have semantic properties on your objects, those properties will make their way across the Rhino and Revit chasm, if you will. So you can continue to edit and use your semantic tools as normal within this paradigm. Okay, I'm going to get into this demo here. So this is actually taken from some of the clips that I showed previously, and I thought what I would do is just kind of discuss some of what's going on in the Rhino model itself and how these kinds of assumptions and considerations make their way into Revit using a variety of different conveyor-based workflows. So this model is set up as a direct Rhino model. This was constituted using conventional Rhino modeling techniques, kind of describing a set of facade panels, shading systems, a couple of floor slabs, out of a drop ceiling, a stair as well. And so some of the things that are important to note here when it comes to Conveyor version 3 is that because we've expanded support for DirectShapes, we are afforded the ability to have more support for categories that can be associated with DirectShapes, meaning if I click on this stair, you'll see that it is categorized as a family, but that we're also able to actually classify this object when it makes its way into Revit as a stair. So if you have view settings in Revit that are stair based or any other element based, those expanded categories are now something that you have access to. So the ability for conversions of ceilings, door types, windows, and stairs is something that is kind of been built into this workflow. Additionally, if I double click into this object, this is a block that's been composed in Rhino. These block components have materials assigned to them. So you can see there's like a cherry wood on the treads here. There's kind of aluminum material on the handrails, glass material for the guards. It's made up of multiple materials, multiple objects, and so this type of assembly is something that would a user would want to translate into the would want to translate to the Revit environment. The same thing goes for this external facade, wherein you have a number of blocks that are defining component assemblies with, again, materials assigned to them as well. And so the first set of workflows I'm going to go to is I'm just going to basically treat this as an external Rhino file. It's already gone through this exercise of having conveyor categories set up and these kind of block elements composed. So I have a kind of a bit of an organized Rhino model here. So I can close this down. So I'll go ahead and save that. And so now in Revit, what I can do is say, okay, I know I have this Rhino file. I'm going to jump over to the Proving Ground tab, and you can see that we have a conveyor toolbar here that's been established. And as I was highlighting before, one of I think the most challenging things for someone that is trying to learn a workflow needs to do is have have kind of an orientation or an understanding of what the workflow pathway looks like. Because as simple as you can make a workflow, if you're not provided with the right amount of context, it can be, a bit of trial and error to kind of figure things out. So we've exposed connections to our website that allows a user that might be new to Conveyor to get access to the latest video learning and tutorials that we provide, as well as the complete documentation setup. So if you're interested in all the different ways that Conveyor can convert a family from Rhino into Revit, we have these kind of task-oriented topical articles written up on how you can, take a Rhino object, like a surface or a mesh or a sub-D object or a block, and convert them over into the Revit environment. All that stuff is documented here. I like the sub-D one because it's got some cool there's some cool geometry there to work with, and that's something that's conventionally really hard to bring into, I think, the Revit environment in a way where these objects can be well situated from a documentation perspective. So our sub-D objects, this is a complete aside, uses mesh-based conversion and some of our novel mesh processing that allows for you to have hidden edge meshes in the Revit document. So you end up with these very clean hidden edge representations of mesh objects. Typically with those, what happens is that you bring those objects in and they have a lot of wires, or they expose the edges of the different poly surfaces, right? So that's one thing that you'll note when you jump into Conveyor V3, is that we're starting to put those help resources at the front end. But the main tool here is the Rhino Conveyor Toolbar, which can be set up as a dockable window inside of Revit. And what I can do here is I can establish a direct connection to that Rhino file. And what that's going to do is it's going to itemize the different objects that are available in that Rhino file for me to bring in with their kind of, I guess, categorical mappings. So as an example, what I'll do is maybe I'll bring in one of the stair objects here as a demonstrator. So I'm going to jump down to the component families. It's going to filter that list. I'm going to uncheck everything except one of these stair objects. So you can see there's a stair object there. And I'll just load that in. And it's going to say that one element is going to be imported in. Again, this is all using an external connection to a Rhino 3DM file. So again, it doesn't require a direct Rhino Inside integration at this stage if you don't need it or you don't want it necessarily. So it allows for that kind of convenience. And what happens is that object that was opened up and created in Rhino has now been brought in as a stair object. It's classified as a stair. It's a direct shape. And it also has I don't need to save. Don't worry about it, Revit. It also has the materials assigned. And what's happened as well is that what Conveyor has done is that it's looked at the material list inside of the Rhino file, and it's mapped it to the available material list inside of the Revit file. So these objects now have materials. And as I indicated before, one of the challenges with DirectShapes is that if I click on this direct shape, there's no exposure to any of the material properties on this object. And while it can serve to support at this stage maybe a visualization using the materials that were assigned, I can slice it and include it in documentation. A user may want to override materials at some point. Maybe they want to change the materials of this guardrail so it renders in Revit differently, or displays in some different contexts. And so that's where this direct shape material utility comes in that we've designed for Conveyor. It allows us to do both wholesale applications of a material to a direct shape, or it'll allow you to apply different materials to different faces. And so what I'm going to do here is I'm going to just jump in and pick a couple of these stair treads like so. And I can then say, okay, well, I want this to be a precast concrete material instead of the wood. And so I can now keep that up to date, or change it on the fly without having to go through the import workflow. So this is kind of one mode of working with Conveyor. You can connect to an external file, bring it over. We've also provided an expansion onto the Rhino Inside integration that's there. So if you have Rhino Inside installed, you can activate Rhino Inside. Some of you Rhino Inside users are probably already familiar with this. You can basically start Rhino as a plugin to Revit. It's a really novel and powerful interoperability concept, I think, for Rhino. And what we're able to do is use Conveyor within that context as well. So we'll just let Rhino Inside open up. There it is. And I'm going to go ahead and close this external Conveyor toolbar there. Now, typically what you do with Rhino Inside, the way that I think people use their plugin primarily is an interface for Grasshopper. You can create Grasshopper definitions that do certain things to the Revit model. There's a player that lets you kind of create batch routines as well. We're primarily interested in just the availability of the Rhino interface because we know that a lot of design work happens through direct modeling. And what we want to provide with Conveyor is just that kind of ability to directly pass your object geometry into Revit from the Rhino interface. So let me go ahead and clean up my space here. So get rid of some of those toolbars so I have a little more real estate. Normally I'm working on 2 monitors. So what I'm going to do here is I'm going to go ahead and open up that same file I had before. Block direct. It's going to open up the 3D model of that block. So there's the direct modeled Rhino objects that have been kind of saved in this file. I had it open as a separate application before. It's now open through Rhino Inside. And what I can do here is I can say, okay, I'm going to select a couple of these objects. And then there is a Rhino-Revit Direct toolbar. And what this allows me to do is say, okay, now that I'm opened up in Rhino Inside, I can say, let's send these 2 floors over to Revit. And it's going to open up a connection and basically send them right into the model. So now we have those 2 floors with, again, materials assigned to them applied. I can also do something like let's send over one of these curtain systems. So here's the main door, I guess. I can send that over into Revit as well. And it's being passed over and it's going. There it is. Now we have that object as well being passed in, again, with the materials assigned to it. There was that question before about different ways with which objects can be passed over. Right now, I'm in kind of a DirectShape mode, because that's kind of what we've been primarily testing with Conveyor version 3. But if I wanted to do something with families, I can certainly do that as well. Family imports tend to be slower because Revit's having to open up a family and create it behind the scenes. But when it comes to importing different objects that aren't on these, these specialized layers here for ceilings, doors, or windows, if I wanted to do something as like specialty equipment, I could have the option of saying, okay, create this object as a family or create it as a direct shape. Those pathways are exposed here in our options for passing information back and forth. This also works the other way. I kind of wanted to highlight that other direction here with Rhino Inside, wherein I might have something like a couple of walls in Revit that I might want to coordinate with my Rhino model, whether it's for visualization or I need to work around them for a different design activity. So what I'm going to do here is I'm going to just go ahead and sketch in a few walls in the Revit environment. Let's say I got a couple of tall walls there going up a couple of stories. And maybe what I'll do is as well make these a little shorter. Maybe 10 feet. Yeah, these are 10 feet. There we go. So got a couple of partition walls there. What I can do with Conveyor is get those objects into the Rhino environment. So I'm going to pull those over. And it's going to grab that object geometry that was created in Revit and now pull it into the Rhino environment. And with Conveyor version 3, the object properties that are associated with those objects are also available as user text. So if I go and check the attribute text on the object, everything I would want to know about that wall object is being pulled into Rhino as well. So, the family and type it came from, the surface area as Revit's computed it, the category. There's just information about other dimensional considerations, volume of the wall, stuff that is typically available through the Revit property menu has been pulled across into Rhino as well. And then what's kind of cool is if I do if I ever decide that, I actually want to change this object, I'm going to pull it out this way, like so. I can choose to, refresh these objects here, which will pull in the latest version of the objects from the Revit environment. Should we pause for some more questions, Steve? I see a few have popped in.
Sure. For material translation into Revit, does it use Revit out-of-the-box material or direct import Rhino material texture into Revit?
Say that again. I'm sorry. I was trying to look for that. For material translation into Revit, does it use Revit out-of-the-box materials or direct import Rhino material texture? So what it does is it's actually mapping material names to each other. So if you have a glass material inside of Rhino, what it's going to do is it's going to look for a material that is equivalently named inside of the Revit environment and assign that material. So it's not creating or recreating the materials. That could get pretty messy, especially if you have your own material library. But what we're kind of doing is we're allowing the user to map between material names and find matches in that manner.
There was a comment in chat about materials and sort of a question about, and maybe you just alluded to this, if someone wants to change, if a client wants to change from your beautiful wood treads to precast concrete, for example, is that a blanket thing you can do pretty easily?
Oh yeah, for sure. Yeah. So if you wanted to change all of these treads, you could either, could do a mass select, could change it in Rhino, bring it back in, or if you wanted to do something like override the entire material of this thing, which would kind of be bonkers. But if you did something like this, jump over to Proving Ground tab, you can override the entire element as well. So you can kind of be like, okay, well, I want to do this whole thing as here. Yeah, so now the whole thing's concrete. Doesn't that look helpful?
Oh boy. We have a kind of a general question about how Conveyor works with relationships of geometry between Rhino and Revit. Is there a relationship between the levels in Revit and other references established in Rhino, like floors in the demo? Are they associated with Revit levels?
So that's actually a really good distinction. What I've done here is that the objects that have been brought over, these are solids. And they could be like any kind of specialized shape that they want to be. So they're classified as floors, but they're not associated with levels. We do provide a pathway for more conventional floors that need to be associated with levels to be imported. So there's this plane here down at the bottom, and this plane has a family type assigned to it. What I can do is send that over to Revit. And what this does is it's because it's not a direct shape, this is a different type of import that I've brought over. This object now has an association with the level. So if I move level 1 up and down, it does have that kind of hosting relationship. It also allows you to, as a Revit user, change the floor type on the fly, because we're in this particular case, passing over a geometry for that's about creating native floors, whereas this might be a direct shape or a more specialized floor. So there's kind of more than one way to import a floor, and it really is going to be driven by your use case.
We actually had a suggestion on this. If levels in Rhino could be snappable geometry instead of text. Add that to your feature request list there, Nate.
You mean, I'm wondering if the user means they can be like, because you can't snap to text. I mean, that you can snap to the kind of level datum that a text piece provides. But I'm assuming that they may want like a plane or a line, right, or something like that, which certainly could be something to get.
We had another sort of general conveyor question. When working with complex roof geometry, what would be the best workflow?
Oh, great question. So it depends on how complex your roof is, I suppose. If it's made up of multiple like panelized components, that might lend itself towards a kind of a more panelized workflow with, say, adaptive components. If you're thinking about like more of a solid type of workflow wherein you have a complex geometry like a doubly curving volume of some kind, and let's see if I can actually mock something up quick here. Just gonna put the old design skills to the test. Look out. There's a caricature of a complex roof, I guess. Extrude surface. I'm gonna make it thick as well. Make it solid. So what you might do is say, okay, I'm gonna make this as a roof. So it's been classified as a roof object. If you were to bring something like this over, likely what you would want to do is have it'll be imported as a roof classified DirectShape automatically, because it's on the roof layer and it's a complex solid. So it's not going to try to assign a type to it. It's going to just kind of try to bring the geometry over as it's been constituted here. So let's see how successful this is. Sometimes there it is, brought over. So there's a roof object that's been classified as a roof, and it has been imported into Revit. So that's one possible way to do it with the kind of DirectShape stuff. Oh, and then of course, if you're like, okay, well, this is kind of what I was talking about before. This has been brought over. There's no real material that's been assigned to this. So you might say, okay, well, maybe this actually needs to be something else when it comes to how it's being displayed. So I'm going to say, okay, I'm going to make this let's see here. I'll just pick something I know has a pattern to it. Obviously, it's not. This isn't oak flooring, but it is now. It's got the materials on the roof object. Other questions?
We had a couple of questions about the product Conveyor. Is there a minimum user limit for an enterprise agreement? And will Conveyor be available in other languages like French?
Good. Both very good questions. So the enterprise setup that we do, these are contract-based, and what we typically do is we engage a client to understand what their usage may be, and we set basically we set pricing based on that anticipated user limit, and then the tool is made available to the company on an unlimited basis. So what that means is that there's no kind of necessarily individual license tracking. We set up a contract with you and your company gets complete access. And so the contract amount might very well vary depending on your company context, how many users we anticipate using this. And then every year we then track and work with the client to understand how the usage has been going and if anything needs to be adjusted in terms of our assumption. In terms of other languages, I would like to, but I should also provide for context. We're a US-based company, and our total company size is 4 people. So in terms of kind of supporting global initiatives, that's in kind of global language support, that's something that isn't quite on the table at the moment, but certainly something that we have ambitions as we grow as a company to ultimately support with our products. So in our current state, we hope to get there, but at the moment it's we're at where we're at on that front.
There's one more question, actually a lot of questions about material and interoperability between Rhino and Revit, and questions about workworkfs on that.
I knew everyone would like materials.
Yes, everyone's excited about materials.
I've been telling everyone. I've been telling the team here at Proving Ground in our daily check-ins. I'm like, I think we've got some really cool material workflows, and Steve and team are like, okay, that sounds
cool.
Great.
Yeah,
you have no idea
how getting traction. Yeah,
like well, you have no idea how important materials are.
So looking at this stair that you imported, can you actually in Revit go into the family editor and select the rail object as an example, and then change the material of that sort of very specific thing in Revit that was brought in from Rhino, right?
So that's a great question. So this is a DirectShape. So it's not a family. You can't take a DirectShape into a family editor. You can override the materials on these faces with a DirectShape to bring them in. However, what I'm going to do maybe is something else here. I'm going to demonstrate a process with families to kind of show that there is a workflow opportunity available when it comes to editing families as well. And of course, that's built out in the middle of nowhere. Let's get a seaplane going. Just trying to get a object model at a reasonable location. And maybe I'll make this 2 objects here. Yes, good. Block this out. Make this a subcategory 1 and subcategory 2. Let's see how that's stuck. Good. Subcategory. Slightly named differently, but that's fine. I am also going to override the material on one of these objects. Get my object properties back up here. Just make that a separate material there. And let's just make sure I'm on, yep, I'm just on a default layer. Good. Okay, so now I have a block here. It's composed of 2 different objects, 2 different subcategories, and 2 different materials. I'm going to move these into the component families category, and I'm going to bring this over as a generic model. And so what this is going to give me as an option, because it's on the generic model layer, this is what I was talking to earlier. I could choose to either import this as a DirectShape, or I can use a family conversion. In this case, I'm going to use a family conversion. So I'm going to keep that the same, and I'll move this over here. Just want to make sure. There we go. So what it's doing right now is it's saying, okay, instead of constituting a DirectShape, it's giving me this option like, hey, you're bringing over something that is a block. We need to create a block definition. So what this is going to do is it's allowing me to create a family that's called Revit block. So it's going from block to family, and then it's going to place the family. So we'll let that go. And I have two monitors opened up. I have a status bar that, of course, is opened up on the other monitor. But yes, there is status indicators of where things are at in the process. Now, I mentioned before that this particular type of translation of families is a little bit more time consuming because it has to open up a family behind the scenes, load the geometry into that family, save the family, then load the family into the model and place it. So there's a number of more steps that occur there. But it does provide you with a family object proper. And what this family object does is it has basically created for us a family that has materials. It's a family, so therefore I can override materials on the object. The families that are imported expose a series of material parameters that I can change on the fly. So if I decide, oh, I actually want this cherry material to be an aluminum material, for example, that is exposed through that interface, and now that's aluminum. I can also double click into this family as well, and this will provide us with the ability to select and update different aspects of this family. So you'll notice that if I click on these objects, you'll see that they have a subcategory assigned because that was established over in Rhino as well. They have a material property that's attached to them. There's also an element here where if you're inside of the family editing environment with one of these shapes, and the object type and shape is simple enough, sometimes Revit even exposes this ability to edit the geometry itself. So if I turn on shape handles for what is essentially a simple extrusion in the family environment, this geometry is editable. It's being established as a free-form element, so I can do Booleans out of it or void forms out of it. I can also edit the shape itself when you go through this family process.
Awesome. We had one more question. Are our prices set in US dollars if other individuals outside the country, like in the EU, Australia, Canada, etc., would like to purchase this? Is that price based on USD conversion?
Yes, it's priced on USD conversion to your currency.
I think we had a lot of excitement about materials, and we covered a pretty good gamut of those. There was a question about if this webinar will be available afterwards, and we typically post these to our YouTube channel. So do a search for Proving Ground on YouTube, and we'll have this video available there shortly. But otherwise, Nate, I think we tackled all of the questions we had.
Well, fantastic. Thanks for moderating again, Steve. Thanks for everyone for your interest in the new version of Conveyor. Again, our goal with this toolkit is to continue providing utilities and workflows that can be adopted by people of a variety of different skill levels, and can scale to organizations where you have skill sets in direct modeling in general, and also support a variety of different use cases when it comes to receiving Rhino information and bringing it into Revit. So hopefully this was a valuable overview of Conveyor in general, but also a highlight of what's coming in Conveyor version 3, which we project to be put out in early February. So thank you so much.